massive rocket stands silently on a launch pad in Florida, surrounded by smoke, fuel lines, and thousands of tons of technology. Engineers watch every number carefully as the countdown continues. This was supposed to be one of the biggest moments for Blue Origin, the space company founded by Jeff Bezos. A powerful test that would move the company one step closer to competing with SpaceX in the modern space race. The timing made the incident even more surprising. Only days earlier, Blue Origin had completed an investigation into problems that affected New Glenn's first flight. Engineers were preparing the rocket's next mission and hoping to demonstrate that the company was ready to move forward. Instead, the program suffered another major setback before the rocket could even leave the ground. Within moments, everything changes. A sudden explosion turns the launch site into a giant fireball, shocking people across the internet and raising serious questions about the future of one of America's most ambitious rockets. The rocket involved in the incident was called New Glenn, a massive, heavy-lift rocket developed by Blue Origin. Named after astronaut John Glenn, the first American to orbit Earth, the rocket was designed to carry satellites, scientific equipment, and future space missions far beyond our planet. Unlike smaller rockets, New Glenn was built to handle extremely large payloads and compete directly with rockets developed by companies like SpaceX. For Blue Origin, this rocket was not just another project. It was the company's biggest attempt to prove that it could become a major player in the future of space exploration. To understand why this explosion became such a huge story, it is important to understand how serious and advanced modern rocket testing really is. Before any rocket can launch into space, it goes through multiple stages of testing. One of the most important stages is known as a hot fire test. During this process, the rocket remains attached to the ground while its engines ignite at full power for a short amount of time. Engineers use these tests to examine fuel systems, engine pressure, temperatures, software behavior, and overall stability. It is essentially a full launch rehearsal without actually leaving the ground. On the day of the incident, New Glenn was preparing for one of these critical engine tests at Cape Canaveral in Florida. Everything initially appeared normal. The rocket stood fully fueled on the launch pad, while engineers monitored systems from a safe distance. As the engines ignited, massive flames and smoke surrounded the base of the rocket, exactly as expected. But only moments later, something went terribly wrong. A sudden explosion erupted near the lower section of the rocket. Within seconds, the launch area was consumed by fire and thick smoke. Videos recorded from a distance showed an enormous fireball rising into the sky, while emergency systems immediately activated around the site. The blast quickly spread across social media, with many people comparing it to previous rocket failures seen in the early days of private space exploration. Fortunately, no injuries were reported during the incident. Space launch facilities are built with extremely strict safety systems, and engineers are usually located far away during dangerous tests like these. Still, the destruction of such an important rocket immediately became a major setback for Blue Origin and sparked intense discussions about what may have caused the failure. At the moment, the exact reason behind the explosion has not been officially confirmed. Investigations are still ongoing, and engineers will likely spend weeks or even months analyzing data from the test. However, the incident became even more interesting because Blue Origin had recently completed an investigation into issues from New Glenn's previous flight. According to findings released before the explosion, a cryogenic leak had caused freezing inside part of the rocket's hydraulic system, affecting performance during the mission. While there is currently no evidence that the same problem caused the launch pad explosion, the discovery highlights how difficult it can be to manage the extreme temperatures and pressures involved in modern rocket operations. Engineers will now examine whether the latest failure was connected to fuel systems, engines, software, ground equipment, or an entirely different issue. One of the most likely possibilities is a fuel system failure. Rockets use extremely volatile fuels that must remain stable under enormous pressure. Even a small leak can become catastrophic once the engines ignite. Modern rocket engines burn fuel at incredibly high temperatures and pressures, meaning any weakness in a pipe, valve, or connection can instantly trigger an explosion. Another possible explanation is engine instability. Rocket engines are among the most complex machines ever built by humans. Thousands of components must operate perfectly together within fractions of a second. If pressure inside one engine becomes unstable or combustion occurs unevenly, the entire system can rapidly fail. In some cases, this creates a chain reaction powerful enough to destroy the rocket almost instantly. There is also the possibility of cryogenic fuel complications. Many modern rockets use supercooled liquid fuels stored at extremely low temperatures. These fuels are difficult to manage because they can affect metal structures, pressure systems, and fuel flow behavior. A small temperature imbalance during fueling or ignition can sometimes create dangerous conditions capable of triggering a major failure. Software or sensor malfunction is another theory experts are considering. Modern rockets depend heavily on computers and automated systems. Thousands of sensors constantly monitor temperature, pressure, vibration, and fuel movement. If one of these systems provides incorrect information at the wrong moment, automatic controls may react improperly, potentially leading to disaster. Although the explosion shocked many people online, failures like this are not uncommon in the history of space exploration. In fact, almost every major space company has experienced dramatic rocket failures during development. Even SpaceX, now considered one of the most successful private space companies in the world, suffered multiple explosions while developing its rockets. Some of its early prototypes exploded during landing attempts, engine tests, and launch experiments. These failures were expensive and highly public, but they also provided engineers with critical information that helped improve future designs. This is one of the harsh realities of rocket science. Building machines capable of reaching space is incredibly dangerous and technically difficult. Rockets carry massive amounts of explosive fuel and operate under extreme pressure, heat, and speed. Even a tiny mistake can destroy years of work within seconds. That is why many aerospace engineers view test failures not simply as disasters, but as part of the learning process required to build safer and more reliable systems. For Blue Origin, however, this incident comes at an especially important time. The company has spent years developing New Glenn, while competitors like SpaceX continued moving ahead rapidly. SpaceX now launches rockets regularly, deploys satellites across the world, and continues developing systems designed for missions to the Moon and Mars. Blue Origin has often been criticized for progressing more slowly, despite having enormous financial backing from Jeff Bezos. Because of this, many people viewed New Glenn as Blue Origin's opportunity to finally prove itself in the heavy-lift rocket industry. A successful launch could have positioned the company as a serious competitor in future satellite missions, government contracts, and deep space exploration projects. Instead, the explosion may now delay future launches, while engineers investigate what went wrong and redesign damaged systems if necessary. The consequences may extend beyond Blue Origin itself. New Glenn is expected to play an important role in launching commercial satellites, including missions connected to Amazon's Project Kuiper internet network, as well as future government and scientific payloads. Any lengthy investigation could affect launch schedules and force customers to wait while the company rebuilds hardware, reviews procedures, and returns the rocket to flight readiness. The financial impact could also be significant. Rockets like New Glenn cost billions of dollars to develop, test, and maintain. A single failed test can destroy expensive hardware and force companies to repeat months of preparation. Beyond the financial losses, public perception also matters. Space companies rely heavily on trust from investors, governments, and commercial customers. Any major accident immediately places that trust under pressure. Still, many experts believe this incident does not necessarily mean the end of New Glenn. Historically, some of the most successful rockets ever built experienced failures during development. Engineers learn from every explosion, every failed engine test, and every design weakness discovered during testing. In many cases, the data collected during accidents becomes more valuable than successful tests because it reveals hidden problems that may have caused even larger disasters during actual launches. The incident also highlights the growing competition in the modern space industry. Decades ago, space exploration was controlled almost entirely by governments and national space agencies. Today, private companies led by billionaires are driving much of the innovation. Jeff Bezos and Elon Musk are now at the center of a technological race that could shape the future of humanity beyond Earth. Both companies share similar long-term goals involving reusable rockets, moon missions, and eventually human settlement on other planets. However, their approaches and progress have been very different. SpaceX focused heavily on rapid testing and accepting failures as part of development, while Blue Origin often moved more slowly and cautiously. This explosion may increase pressure on Blue Origin to accelerate development while maintaining safety and reliability. As investigations continue, engineers will analyze massive amounts of data collected during the test. High-speed cameras, pressure sensors, fuel readings, engine performance logs, and structural information will all be examined carefully. Only after this process is complete will the company fully understand what caused the explosion and how to prevent similar incidents in the future. For now, the exact cause remains uncertain, but one thing is clear: the road to space has never been easy. Every rocket launched today stands on decades of failures, accidents, and experiments that push technology forward little by little. Behind every successful mission are countless setbacks that most people never see. The explosion of New Glenn serves as another reminder that space exploration is still one of the most difficult challenges humanity has ever attempted. The technology may appear advanced and futuristic, but reaching space safely remains incredibly dangerous. One small failure inside a machine carrying thousands of tons of fuel can turn years of engineering into flames within seconds. Yet despite these risks, companies continue pushing forward because the rewards are enormous. Space technology affects communication, navigation, science, defense, and potentially the future survival of humanity itself. Every launch, every mission, and even every failure contributes to the larger goal of expanding human presence beyond Earth. Blue Origin now faces one of its biggest tests yet, not only as an engineering company, but as a competitor in the rapidly evolving space race. The company must now determine exactly what happened during the test, repair damage at the launch site, and prove that New Glenn can fly safely and reliably. The coming months will determine whether this explosion becomes a temporary setback in the rocket's development or a major obstacle that slows Blue Origin's ambitions for years to come. And maybe that is what makes stories like this so fascinating. Space exploration is not a smooth journey of constant success. It is a dangerous process filled with uncertainty, ambition, risk, and failure. But every explosion, every destroyed rocket, and every setback teaches humanity something new about how to reach farther into the universe than ever before. Because in the end, the path to space has always been built on trial, error, and the willingness to try again. If you want more real space, mystery, and science stories like this, make sure to subscribe to Nexora and stay connected for the next one.